Hi everyone, we are on page 39 of our manual and this is lecture 4, rates of reactions. So most of you were in class during this. This is a recap of what we did and information for people that were missing that day. So the topic here is rates of reactions. Okay, so rate of a reaction is the change in the concentration of a reactant or product per unit of time. Okay, now to understand this lecture, I want you to think of this. Think of chemical reactions as collisions between particles. Okay, so particles colliding with one another. Okay, only when the particle collides can there be a chemical reaction. Now, we can speed up those collisions, we can slow down those collisions, and that's something we'll be looking at in the next page, factors affecting the rates of reactions. Okay, so at the minute, I want you to think of chemical reactions as collisions between particles. So, a rate of reaction then is the change in the concentration of a reactant or product per unit time. Now we can look at it by measuring the amount of either the reactant or the product that changes per second. Okay, so if we look at a general chemical reaction, a reactant will make a product. Okay, now at time zero, T0, that's when at the start of the reaction, you have 100% of your reactant, but yet you have 0% of your product. Now, at the end of the reaction, T end, you should have 0% of your reactant and 100% of your product. So you can measure then how much this changes over time, or how much this changes over time. So that's how you can measure the rate of a reactant, by either seeing how much the reactant or the product changes per second. Then from that we can get the average rate of reaction by dividing the overall change by the overall time. And the experiment that we were due to do in week 9 of the semester is all based on this, and we can measure the rate of reactant. So remember, collisions between particles is essentially chemical reactions, and we can measure the rate of them. Now, I'm going to give you a definition here that you will need for the rest of this lecture, and it's called activation energy. Activation energy, right? It's the minimum amount of energy a particle requires in order to collide with other particles, i.e. react. Okay. Another way to look at it is the energy required for effective collisions. Okay, so just to recap, activation energy is the minimum amount of energy a particle requires in order to collide with other particles, i.e. react. Another way to look at it is energy required for effective collisions. Now the word effective there is very important because particles can collide and bounce off one another, but if they don't have a specific amount of energy, i.e. activation energy, they won't cause, that collision will not cause a chemical reaction. Okay, so both particles in the collision needs a certain amount of energy, a minimum amount of energy in order for the collision to be effective.